Before writing our own flow, we're going to need to take a look at two classes. One is the transaction builder class, which is used to create a new transaction, and the other is the flow logic class, which represents flows. So let's start with the transaction builder class. So double tap shift, open up transaction builder. There you go. And this is the definition of the class here. So you can see there's a fair bit going on, but up here you've basically got all the various components of a transaction. So you've got a notary, the inputs, the outputs, the commands, as well as some things we haven't looked at too much, such as the time window and attachments. And the purpose of a transaction builder is just to give you a mutable transaction container that you can add things to. So once your transaction becomes signed, then it's effectively immutable. You can no longer modify it without breaking those signatures. So the workflow is to create a transaction builder, add the various inputs, outputs, commands that you want to add to it, and then finally you'll be ready to sign it to convert it into an immutable version of itself. There's a lot of methods in here, most that you don't need to worry about today. But the main ones to look at are these add ones. So here you can add an input state, you can add an output state, you can add a command, and there's all kinds of wrapper methods for adding things to the transaction builder. And you can also verify the transaction builder. So at any point you can check that the transaction builder is valid. And calling verify will actually go through and call verify of all the various states that you've added to the transaction builder over time. So it'll allow you to check that the transaction builder that you're building is valid. So the easiest way to give you a feel for how the transaction builder works is just to have a worked example. So let's just open up a new file here. We'll call this Scratchpad maybe, it's a Java class. And it'll just be a place for a main method where we can start to just show you how a transaction builder works. There we go. So we create a transaction builder using, as normal, standard Java syntax. So here we're going to say transaction builder equals new transaction builder. There we go. So that's our builder there. And now we have our builder. We can just add a bunch of things to it. We can add commands, we can add output states, we can add input states. And so there's all kinds of methods here for adding stuff to the transaction builder. So we can, for example, let's just declare some input states up here. So let's say we have contract or state and ref contract state input state equals null. So we're going to leave this as null for now. So we'll see in a second flows how we create instances of states. We don't need to worry about that for now. And then here we're going to have a contract state output state. And here we can just instantiate it relatively straightforward. So here we're just going to say we're going to make a new house state where it's a string of 1, 2, 3 more field road and an owner of null. So again, obviously normally we wouldn't pass nulls here, but in our case we just want to get started showing the transaction builder, so we'll allow it. And we can also create a command here. So what we might do is get first a list of required signers. So here we might say list of public key required signers equals output state dot get owner, let's say. So here we need to declare this as a house state up here. Sorry, just doing some housekeeping. And then we're going to get the owning key. So here we call this required signer, and that should be a public key. And let's say we want to make a list of public keys, which is the list of required signers plural, then required signers equals immutable list of required signer. There's no requirement that you use immutable list or anything like that. That's just a Guava helper class to have a relatively terse syntax for creating lists of public keys. But don't need to worry about that now. So here we're just creating a bunch of kind of dummy classes that we're going to use as fuel for our builder. So our builder now, we can just say add input state, and we can just pass in the input state from above. And there's two ways you can use the builder. You can either use a this standard syntax where you're just adding stuff over time. So here we say add output state, etc. builder dot add command, etc. Or you can chain these things in true builder style. So you can say add input state, then add output state, and then add command afterwards. And so add input state, we just pass in the state we want to consume. That's all straightforward. And the state here is already associated with a contract, so you don't need to pass the contract. When we pass the output state, it's a little different. We're passing a new state that doesn't exist yet, one we've just created above. So we have to pass in the output state, but we also have to pass in a contract. We have to say which contract is going to govern the output state, and this is where you associate it with your contract. And so here I need to pass in the fully qualified name of the contract, which would be Java. So this will be as a string, Bootcamp, and let me just go check that. Java Bootcamp dot house contract. Now, the reason we have to pass it as a string is because we don't actually want to pass the class, because that would create a trust issue where everyone would use the version of the contract provided by the transaction builder. And what happens if that contract is actually a fake dummy contract that's invalid? So instead of actually including the contract in the builder, we're just going to pass the name of the contract to use, and then each party on their own machine will load that from the class path and use that, so they don't have to trust the builder to provide valid contract. So we've had an input state, we've added an output state, and here we can just add a command, and we're going to add command takes two things, the command data type. So here, let's say we want to create a new house contract dot register. It's going to complain here, I believe, because house contract, the commands inside are not static classes. So to reference them inside the contract class, we need to mark them as static. Let's do that now. And then that should sort that out. And then to add the command, we need to not only pass the type of the command, but also the required signers, which we've defined above, just a list of public keys. And there you go. So now we have our builder. So we've created our builder to start with up here. We've added an input state, we've added an output state, and we've added a command. What else can we do with the builder? Well, the next thing we probably want to do is verify the builder. And there you go. And so to do this, you need access to this object called the service hub, which we haven't introduced yet. And we'll talk about in the next section of the live coding. But you can see that you can verify the builder to check you've done the right thing. And then once you've verified the builder, then you can sign it and it becomes a fully signed transaction. There's just one last thing we need to do here. When you build a transaction, you need to pass in a notary as well. Either you can pass it in the constructor, or you can specify it later by saying builder set notary and pass a party here. And so again, we're just going to create a null entity here. So we're going to say party notary equals null. And we're going to see later on in the flows how you'd actually get a reference to a real notary to add to this transaction. But there you have it. So we've just created this simple example class where we're showing you some of the syntax you'd use with the builder. So generally, you add the input state just by adding a state and ref, a reference to an existing state on the ledger. But then when you add the output state, you actually need to create that output state from scratch because it doesn't exist yet. So the input state already exists and is being consumed. The output state doesn't exist. And so this is the replacement state almost that you're proposing. And because the input state has already been associated with a contract at the time it's created, but the output state is brand new, so you need to choose the contract that's going to govern it. And then finally, you add a command. So here we're adding a command of type housecontract.register with the required signers being the key of the owner of this output house state. And the other class that we need to look at is flow logic. So let's pull that up now. And flow logic is the class that every flow on the platform must extend. So you can see here it's a class, but it's an abstract class, meaning it must be overridden. And there's the various things going on here, so things to log information about the flow, etc., etc. But the main thing you have to look at is this call method, which is further down, possibly right near the bottom. Let me just do a quick search. And here you have this abstract call function. So this is the only abstract function in the whole of flow logic, and this is the one you need to override. And call is where you actually define the logic of what your flow will do. So let's just take a kind of a work example and do some live coding. So let's just create a new class again and say here, we're just going to call this the very simple flow, let's say. And so we have our class here, and all we need to do is just implement or extend even, the flow logic class. And flow logic takes one generic, which is just the return type of the flow. So here we're just going to pass void. It's complaining still because I need to implement this call method. And there you go. And so here we have our flow. So we can just do whatever we want in here. There's one thing we have to do before we begin, which is we need to annotate this method as suspendable. So under the hood, Corda uses a library called Quasar to allow flows to be paused and checkpointed at any point in time, and to allow this the bytecode rewriting that allows them to be checkpointed and suspended at any point in time. Every call method must be annotated as at suspendable. And be careful, because this at suspendable annotation won't be automatically added when you use IntelliJ shortcuts, for example. But now we have our flow, and we can write the call logic. And here, for example, this is a valid call. So this is a flow that would exist on your node, and whenever you start it, you just return null. You could also return 1. And here we just modify the return type so it returns an integer. There we go. So that's our flow that returns 1. Or what else could we do? Well, we could do a flow that returns, that does some arithmetic. So here we could say int a equals 1, int b equals 2, return a plus b. And there's really no limits to what you can do. So you're just here working in terms of standard, Java functions. You're just asking your node to do something. So you could also have a function here. So you might say public integer return 1, return 1. And then here you might call that function. And so you can call that to other functions. You can use all kinds of libraries. So here you can make lists or define your own classes. There's really no limits here. So you're very flexible within the call method in terms of what you want to do. And so we'll look at a more complicated example in a sec. There's just a couple more annotations I wanted to show you. So one annotation you might want is this one, initiating flow. And this means that it's a flow you can start on the node directly. So there's some flows that are the opposite, that they're initiated by, and this means they're started in response to other flows. But this one we've written here is going to be an initiating flow. So the node owner will just start the very simple flow and get the result of 1 plus 2. You can also, and you want to, in this case, annotate it as startable by RPC. And that just means that the node owner, when it's logged into the node via RPC, can start it directly. So you've got some flows that are initiating flows that aren't started in response to other flows, but are started just by the platform or by a service within the node. By marking it as startable by RPC, you're essentially saying this is a flow that the node operator can start. So let's go a bit further now and actually look at a flow that shows communication between nodes. So let's start another class. We might call it the two-party flow. So again, we have our class. We need to extend the flow logic interface. In this case, we'll return an int again, perhaps, integer. And we need to implement the call method, which we need to mark as @suspendable. So it can be suspended at any point. So what we're going to do differently in this flow is we're going to have two flows speak to each other. So we're going to annotate this one as an initiating flow. Perhaps we want to make it startable by RPC as well. And then we're going to create a response flow. So here we're going to create, and here we'd have to create this in a separate class. So I'm going to open up a two-party flow responder class here. And I'm going to extend, again, flow logic. I'm going to have it return a void in this case, I don't care. I'm going to implement the call method and mark that as @suspendable. And the important thing here is this is a flow that's going to respond to some request from the two-party flow. So we don't want to mark this as initiating or startable RPC. Instead, we want to mark this as initiated by two-party flow.class. And what this does now is once we install this Corda app on the node, then this node will add this two-party flow responder to its list of responder flows. And effectively, what does that mean? Well, it means that whenever the node receives a message from an instance of two-party flow, it's going to go to its list of registered responders. It's going to check if it has a valid responder to two-party flow. It's going to look through its list. It's going to find that because this annotation, yes, two-party flow responder is annotated to respond to two-party flow, and it's going to create an instance of this flow to speak to two-party flow. And so we've effectively set it up so communication can happen back and forth between these flows. And so first of all, we need to do some sending on this side. So what we might do here is say send some information. And so what do we need to do as send? Well, the first thing we need to do is we need someone to send it to. So let's create a constructor for our two-party flow. So we're going to create a public two-party flow constructor. And we're going to create a field, which is, let's say we're going to call this party counterparty. There we go. So again, here we're talking in terms of parties. And so this is a party on the network we were going to want to send some information to. So here we're going to say this.counterparty equals counterparty. Pass that up here. There we go. So now we actually have a constructor for our flow. And so when we call the flow, we can pass arguments to it. So we can now call this flow and speak to any counterparty we want. And so here what we're going to do is we're going to want to speak to that counterparty. The first thing we need to do is create a communication session with that party. So here we go. Flow session equals initiate flow counterparty. Now this session is almost a channel of communication. It's a way of sending and receiving messages between the two flows. And this is how all communication between nodes happens. So anytime you want two nodes to communicate, you as the node operator don't speak to their node operator directly out of band. Instead, you send requests to your node, you start flows on your node, and it's in the context of those flows you'll go and speak to a counterparty node. And here I might say session.send, and I'm going to send the number 1. And hopefully they're going to increment that. So now if I go to the counterparty, well, any responder flow actually must have a single constructor, which is of type two-party flow responder, and takes a counterparty flow session. So here we're just going to pass that in. Let's call that counterparty session. And we're going to store that locally. So private counterparty session. And this counterparty session equals counterparty session. So this is just a constructor that's expected for any responder flow, and this is the constructor the platform's going to use to set up and instance this flow. So when your node receives a message from someone running two-party flow, they're going to start a flow session with you, and in the process of creating that flow session, they're going to create an instance of this flow to respond. And so now we have access to this counterparty session. And so what we can do now is say counterparty dot receive, and what do we want to receive? We want to receive an integer. There we go. Now, we've received this integer, but the type of this receive is actually, you can see here in small, untrustworthy data. So you need to do some checking on this data when we receive it. And we do that using this unwrap function. And so here I can just do a very simple thing that just does no validation at all. But you might also do, if I can remember how to write lambdas in Java, I might say if it's greater than 3, throw new illegal argument exception, number too high, and then I return it. And that will give us an int here. So int received int equals that. So you can see here, so we have access to the session with the counterparty. We choose to receive an integer from them. That's in response to their decision to send an integer. So they send an integer, we receive an integer. So all these calls have to match up, and otherwise you'll get all kinds of exceptions, and the platform will make it clear to you there's no correspondence between the logic on the two sides. Then we have to unwrap it. So the unwrapping here is very trivial. It's not important. But you can imagine if you're receiving a signed transaction or some kind of document, then there would be a lot of things you could check here. So we've got our received int, and here perhaps what we're going to do is just we're going to increment it by 1. So we're going to say received int plus 1 equals received int plus 1. There we go. And then we're going to send this back to the counterparty. So counterparties are flow sessions are used to send and receive information. So we're going to send back the received int plus 1. And that's the end of our flow. So the responder basically receives a number from the counterparty no bigger than 3 and sends it back plus 1. Let's go to this side now. So if you think on the responder side, we've received an integer and then we've sent one back. And so here on this side, we've sent an integer and now we need to receive one back. So here we're going to say int received incremented integer equals counter session dot receive integer dot class, and then just do a quick unwrap here. Don't do any checking. We use a lambda there to unwrap. And then we can return this received incremented integer. So here we've written a flow, which is an initiating flow that we can start via RPC. Once we install this on our node, we can always call the two-party flow, choose a counterparty by passing it in the constructor, and saying, I want to start a flow with the counterparty, I want to send them a number, in this case 1, and I want them to send back that number incremented by 1. To make this a little more realistic, to kind of stretch the definition of realistic, then we might also allow you to pass in the number as an argument. So here you have, you might say integer number, and he'd say this dot number equals number. And then you'd use that number down here as an argument in the send. So now you've got a slightly more useful flow, which basically allows you to speak to a counterparty, you send them a number, and they send it back incremented by 1. And so we've got these two annotations here. We're defining this logic in the call function, and this is a flow logic. And we've marked call as at suspendable. So there's various things you need to remember to do, and there's various examples you can use. And on the other side, it's a flow logic again, but this time initiated by this two-party flow, this initiator flow. Again, we have a constructor here which takes the session with the counterparty we're speaking to. And then inside the call function where we define the logic of the flow, we receive this integer from the counterparty, we check it in some way, we add 1 to it, and we send that back. And so effectively now we've set up a flow that allows for two-way communication between nodes. And you can imagine how we can take these basic tools and extend them to allow the agreement of ledger updates or business negotiations between nodes. And the final piece of flow logic API you need to be aware of is just the service hub. So the service hub is this object that's available to the node inside flows. And basically we just call get service hub and we get access to it. And the Service Hub is a portal to all the various services the node offers. So inside the Service Hub, we'll have a list of past transactions, of states we know about, of the network map. It gives us key management, the ability to create signatures. So it's often just a case of routing around inside the Service Hub and seeing what's there. So if you're writing a flow and you think, oh, I need access to some information about my own node, or about a counterparty node, or about some state I've stored or some transaction I was involved in, then generally what you want to do is go to the Service Hub. So you can go and look at the declaration of the Service Hub here. And so it's got a vault service where we store past states, a key management service which manages our private keys, a service for upgrading contracts, storage for all our past transactions, a cache of the network map where we can go and look for counterparties, a clock, information about ourselves, and all kinds of helper functions to record transactions, to sign transactions, etc. So the API is a bit vast to go through in the case of this bootcamp, but it's just one of those things you need to always have in mind when you're looking for information. So if at any time you wanted to extract existing states from your node, or what you might do is say service hub dot vault get vault service. So the vault is where you store all your existing states, and they might say query by, and we might query for house states. There you go. And this would return so here we'd want to get the actual states from those results. And here what we'd get would be a list of house states from vault equals this. So let me just import that. And so here we've got a list of all the states our node is aware of. And so this would actually be a state and ref wrapped around a house state in practice. There we go. But there we go. So that's an example of using the Service Hub to get some information about our node. In this case, some states from the vault. Another example might be getting the identity of a specific party. So we might say get node by legal name, and here we'd pass in a Corda X500 name. And so let me just split this onto two lines. So we might say Corda X500 name, Alice's name equals new Corda X500 name, Alice, Manchester, UK. So that's the name of someone. And then here we're going to get the node that has that name. So we're going to say Alice's name here. And this will return a party called Alice. And so again, that's an example of using the Service Hub just to retrieve some information about the node. That would actually return Alice's node info, which includes information about who she is, what her identities are, her address, etc. There we go. And finally, we can do something like get information about ourselves. So we go to servicehub.getMyInfo, and then we could say, I want to get all my legal identities, or I want to get all my addresses, or I want to get my platform version. Here you go. And so I think that would be an integer. Am I right? Yeah. So here we'd say int platform version. There you go. So there's all kinds of things you can do with the Service Hub, but it's basically a way of accessing any information your node might hold that you'll need in the course of the flow. So that's all the flow APIs we need to look at. On the one hand, we had our transaction builder, which we saw earlier, which allows you just to create a kind of a transaction in construction and then go around adding input states, output states, commands before verifying and signing it. Now that we've seen two-party flows, you can imagine one of the benefits of the builder is the ability to bring together inputs, outputs, commands from various parties and build them all into a single transaction. And the transaction builder remains mutable until the first person signs it, so you can build it up in a collaborative manner in that way. For example, Party A might know about a certain existing cache state, and Party B might know about some existing bond state. And so Party A can take the transaction builder, put in their cache, and then get the bond from the other party and put that in as well, and keep evolving it until they've got to a state where they're happy and the transaction is valid, and then finally sign it. The other thing we looked at were flows. So we've got one here. And flows must extend the abstract flow logic class with a generic of the type that they return. And they have this call function where you define the logic of the flow, And so here we're doing various things in the flow. We're doing some back and forth communication, but it's important to remember some of these annotations. So you can mark something as at suspendable, which means the quasar library is able to checkpoint that flow at any point and revive it when it's ready to work on it again. And then we have initiating flow and startable RPC. Initiating flow means you can start it directly instead of in response to other flows. Startable RPC meaning it could be started by the node operator. And then we also have our responder flow here, which is initiated by the two-party flow class.